Hi everyone, I'm Carl Dong from Chaincode Labs, and I'm here to talk about libbitcoinkernel, a project I've been working on that aims to extract Bitcoin Core's consensus engine. When we download and run Bitcoin Core, it's nicely packaged into a single bundle, a single application. However, those of us who have studied the blade knows that Bitcoin Core, just like most applications, is in fact a collection of subsystems. Those of you who've attended meetups like BitDevs before, or used the Bitcoin Core suite of applications and toggled the options, or just know a little bit about Bitcoin Core architecture, will perhaps recognize some of these names. At the heart of it all, though, we have what I call the consensus engine, otherwise referred to as simply validation. Now, why did I refer to the consensus engine as the heart of it all? Why is it so gosh darn important? It's because the consensus engine is the subsystem which keeps track of all the blocks and the UTXO set. In fact, if you look in the right folders on your machine, you can find these files. Now, not only does it keep track of the blocks and the UTXOs, it is also the arbiter of truth when it comes to what constitutes a valid transaction or a valid block. Essentially, it is the piece of code that defines what the Bitcoin blockchain is. That's why it's so gosh darn important. Since the consensus engine defines what is valid, it is then crucially important in a distributed system such as Bitcoin to make sure that the consensus engines of all the participants all agree. When a new block is mined, and the consensus engines disagree between nodes, that's when unintentional hard forks happen, and that's the nightmare scenario that keeps Bitcoin developers up at night. Great, now that I've hammered home how important the consensus engine is, I'd like to return to our map of the Bitcoin subsystems. So when I lay it out like this on the slide, everything looks so nice and tidy, it almost seems like we've got a well-organized code base. However, the reality is, in fact, much more like this. The main problem here is the tight coupling and entanglement between the consensus engine and the rest of the code base, which means that there's an ambiguous and ill-defined boundary between what is part of the consensus engine and what's not that leads to problems. I know you guys are getting a little bit sick of me saying the phrase consensus engine, but I'm going to say it a few more times. All right, now, for example, it can sometimes be unclear when we make a change to the code base, the Bitcoin Core code base, whether or not it affects how our consensus engine behaves. Remember what I said before about how disagreements between the consensus engines of various participants and nodes across the network can lead to catastrophic forks, and you can see why this can be a big headache. Resolving this problem, this entanglement problem, is one of the key goals of the libbitcoinkernel project. We want to modularize, or in other words, extract out the consensus engine such that we have a more precise view of what our consensus engine depends on, or in other words, what is consensus critical, and how the rest of Bitcoin Core interacts with it. With regards to Bitcoin Core development itself, this also means that contributors and reviewers, when they're looking at a change, or if they're making a change, can have a clearer sense of how security critical that change is. Another big problem that arises out of the need for distributed consensus on the Bitcoin network is that developers with an experimental streak may want to re-architect parts of Bitcoin Core. They may very well want to replace the peer-to-peer system, perhaps get rid of the mempool completely and send transactions straight to miners, or wholesale replace all of our RPC mechanisms with the greatest and most efficient RPC system in the world, gRPC. You can, there's a lot of things that you can imagine people will want to do with our system. Additionally, other developers may want to wholesale re-implement parts of Bitcoin Core in another language. If you have a badge-carrying member of the Rust Evangelism Strike Force on your team, you know exactly what I'm talking about. They're going to want to turn these subsystems into artisanally crafted crates and brag about how they never, ever, not even once, clone memory. The challenge that these developers of alternative implementations face is that they are faced with three options, and in my mind there are three bad options. They can try to get the code through the review process into Bitcoin Core, but the Bitcoin Core project wants to avoid too many features and toggles because they bloat the code base. So you end up sort of with the choice of either imposing a maintenance burden on reviewers and maintainers, or having features that are not well maintained, which is also a problem. These developers may also want to maintain their own fork as an alternative. I note that this is a code-based fork, not a network fork. This is a burden on these developers then, as it is a huge hassle to rebase over Bitcoin Core's code base every release or every few releases, as the Element project devs can attest to. Or, as most do, projects and people implement their own consensus engine. And that means risking any language-specific quirks or nuanced difference in implementation, leading to incompatibilities and into unwanted forks, which we talked about before. So, extracting out the consensus engine into a reusable library, the thing we've been talking about this whole time, means that there can be a relatively stable API, or at least relatively stable compared to the internal structures of Bitcoin Core anyway, that these developers can code against, and be sure that they are consensus compatible with the rest of the network, sort of enabling safe and easy experimentation. On a more personal note, I think that it speaks to the strength of the Bitcoin community that we have experimenters who want to push Bitcoin forward. In other words, I think that they are an asset, and I want to lower the cost of safe experimentation. So, how do we get there? How do we get to this promised land where our consensus engine is decoupled from the rest of the code base and made into a library? Let's first look at some previous attempts at this problem. Those of you who followed Bitcoin Core development for a while may know that there was a libbitcoin consensus. Actually, there is a libbitcoin consensus that was shipped starting with Bitcoin Core version 0.10. In fact, it's been shipped with every version of Bitcoin Core since then. However, libbitcoin consensus is an incomplete library. It only supports script verification and doesn't even manage the UTXO set, the block tree, or do any block validation. Following that, in 2016, there was a brave effort to complete libbitcoin consensus, which I would characterize as having perhaps crumbled under the weight of its own ambition, as it started with building a minimal Bitcoin consensus interface with decoupled storage and caching, with a C interface, and perhaps was a little too much all at once. I think that given how these previous attempts turned out, we need to devise a new plan that takes into account and respects the sheer size of work that extracting the consensus engine. In my mind, this is work that will involve multiple contributors. It's certainly not a one-man job, and perhaps span across multiple releases. I think that we need to take an incremental approach to extracting the consensus engine instead of trying to build a perfect library from the ground up out of nothing. So what does taking an incremental approach, as I mentioned, mean? On an abstract or logical level, it means that we first capture a rough outline of what our consensus engine is today. Once that's done, we can whittle it down to what we would like our consensus engine API to look like, or what it should be, and make it available to other languages via bindings. This, whittling it down approach has the benefit of avoiding prematurely optimizing for the perfect boundary and API, since that can be highly subjective, non-obvious, and probably a hotbed for unproductive bike shedding. On the code level, it means that we will also be able to reuse our existing C++ classes, as ugly as they are, and gradually simplify them as we're making bindings available to other languages. This means that we will always have one user, as in we'll be continuously integrated with Bitcoin Core. It also means that every step along the way, we can benefit from Bitcoin Core's extensive test suite. Perhaps we can have something like a CI job that enables an experimental configure flag that will link Bitcoin Core against libbitcoinkernel, and that will be possible. Okay, so let's talk logistics. Right now, I'm in the middle of completing a candidate branch of the extraction phase, which will yield a libbitcoinkernel that has an API that's very Bitcoin Core specific, but is usable by an external C++ project. This phase will also include a dummy binary, which uses this library and sort of exercises our consensus engine a bit just to prove out that it works. What I've realized after experimenting with this branch over the last couple of months is that the biggest value add of this first phase, this extraction phase, is that after it's merged, any re-entanglement of consensus with new modules will result in linker errors. In essence, there is a big value add just to be gained from the first part alone, in that we will avoid any entanglement regressions. My hope for the next phase is that there would be strong collaboration between contributors to continually refine our consensus engine's interface. At this stage, should users of libbitcoinkernel other than Bitcoin Core emerge, it would also be incredibly helpful to get their perspective on how the API could be made more robust and how it could be made more ergonomic. Okay, in closing, it is my sincere belief that libbitcoin kernel can be a project that improves the Bitcoin network safety, increases Bitcoin's longevity, and one that enables more consensus-compatible experimentation. Thank you all for listening.